First up, supply chain security. You're going to hear the term shifting left a lot, and this is exactly what it means. It's all about embedding your security checks right into the development process. The goal is simple, but man, is it powerful. Find and fix vulnerabilities on autopilot, way before they even have a chance of hitting production. I want you to picture this as a series of automated security gates. First, your code gets built into an image and then immediately scanned. If it's clean, no vulnerabilities, it gets what's called an attestation. Think of it like a digital tamper-proof stamp of approval. And then at the very end, there's a final gatekeeper that checks for that stamp. No stamp, no deployment. It's that simple, and it's all automated. And this slide, this just nails the concept. Binary authorization really is like a digital bouncer standing at the door of your club, your cluster. Its only job is to check the ID. Did this container image come from our trusted pipeline? Did it pass all the security scans? If the answer is yes, it gets in. If not, it's turned away at the door. It's simple, it's effective, and it's automatic. And here's what that looks like in the real world. It's totally black and white. An unsigned image, maybe one a developer just built on their laptop, gets blocked. No exceptions. The only thing allowed in is the signed image that went through that whole approved pipeline. This is how you take human error out of the equation and just enforce the policy, period. Now, securing the pipeline is just one part of the puzzle. You've also got to harden the machines themselves. For the exam, you need to know these two concepts. First, shielded VMs. These basically make sure that a VM's boot up process hasn't been hijacked. And second, distroless images. These are super minimalist containers. They have your app, its libraries, and that's it. No shell, no extra tools, which means way fewer places for an attacker to get a foothold. So how do you make sure your environment stays secure? Things change, right? That's where these two services are a killer combo. Security Health Analytics is like your 24/7 security guard, always scanning for things like public buckets or firewalls that are too open. And then Cloud Asset Inventory is your historian, keeping a perfect record of every single change. You put them together, and you can instantly spot when things have drifted away from your secure setup. Okay, so we've covered the proactive stuff, the walls and the gates. Now we're going to flip the coin and talk about the other side, how you can actually see what's happening in your environment and, respond when things go south. This is all about visibility. This isn't just some abstract exam question. This is the real deal. This is the kind of question that lands on your desk and you need an answer for right now. Being able to answer this immediately is the entire reason you have a logging strategy in the first place. If you don't have the right logs, you are completely flying blind. Okay, this slide is basically your cheat sheet for logging on the exam. Don't just memorize the log types. You've got to understand the strategy. Admin activity logs, that's your non-negotiable audit trail of who did what. Data access logs, that's your go-to for investigating sensitive data, and you send them to BigQuery so you can run crazy detailed queries. And for network forensics, you combine VPC flow and firewall logs to get that full picture of who's talking to who. So you've got all these logs being created all over the place. But how do you get them where they need to go? Well, that's the job of a log sync. And don't overthink this. It's really just a smart conveyor belt. It's a rule that says, hey, any logs that look like this should get sent over to that destination. That's it. So where are you sending these logs? Well, the destination totally depends on the job you need to do. If it's for long-term archival, maybe for compliance, you're going to use cloud storage and lock it down so it can't be changed. For deep dive forensic analysis with SQL, it's got to be BigQuery. And for real-time alerts or feeding into another tool like a CM, PubSub is your go-to streaming pipeline. With all these different systems creating alerts, you run the risk of just being flooded with noise. And that's the exact problem Security Command Center is designed to solve. Think of it as your main security dashboard, your single pane of glass that pulls in all the findings from everywhere and tells you, hey, pay attention to this first. The real power of Security Command Center is just how much it pulls together. Look at this. It's not just looking at one thing. It's grabbing findings from misconfigurations, from threats it sees in your logs, from active threats inside your running containers and VMs, everything. And by seeing it all in one place, it can help you connect the dots and focus on what's truly important. All right, let's bring it all together. We have covered a ton of ground, but for the exam, you need to have the core principles locked in. So let's focus on what you absolutely, positively have to remember. Okay, this is it. These are your key takeaways for Section 4. First, remember that Google Cloud wants you to think about enforcement first, not just detection. Think binary authorization. Second, you have to have a centralized logging plan and know your sync destinations. Third, know that SCC is the great aggregator. It brings everything together. Fourth, always connect your automation pipeline to your security gates. And finally, know the difference between network metadata logs and full packet inspection. You've got to burn these points into your brain. And really, this is the question at the absolute heart of this entire section of the exam. It's not enough to say you configured something. The exam is testing whether you can build, manage, and monitor a security system that is truly operational, that it works day in and day out in the real world. All right, good luck with your studies.